Previously we started looking at this Amiga CDTV. Now we fitted some missing ICs, we fitted replacement ribbon cables, and we repaired the eject mechanism. But it doesn't work. So let's try and fix it. So I've marked out some key pins on the CPU just so that we can have a preliminary look. We want to look at the clock, we want to look at the reset signal, we want to look at the halt signal, and we want to look at the read-write signal just to see if anything is going on. So that's the read-write up here: E, reset, clock, and halt. So power up to the system. We've got the front panel display. Let's power it on. Okay, so the first thing that we want to look at is pin 15, which is the clock. That is this one. And yes, we're getting a clock. Seven megahertz, so that's okay. 20 is the E signal, which I think is divided down. That looks okay. At least I guess it's okay. 710 kilohertz. So that's what, divided by 10. Reset is pin 18. That's high, that's good. Halt is pin 17. That's low, that's not good. Halt is active low, that halts the processor. So I wonder what causes that to be halted. Pin 9, read write. Let's just check that. That's doing nothing. So let's look at some data and address lines. I think the data lines are at the top here. Just pick some at random. No bus activity for sure. But we do have a clock. So what's that likely to be? Let's just try something. This jumper here, I've turned the machine off and it's powered down at the mains. This jumper here, JP15, turns off the CD-ROM stuff. So if we take the jumper off, and it doesn't matter whether it's on those two pins or those two pins or those two pins, if we take that off, that should remove the CD-ROM from the system, and it is now, in theory at least, just an ordinary Amiga. So let's boot that up and see if we have the same issues. Right. So we're expecting to see the clock. We do. It looks the same size. I can't help thinking that should be nearer to 5 volts. E looks the same. Reset is still high, that's good. And halt is still low. That's not so good. Now one thing that we don't know, these caps were put in by somebody else. It's going to be worth checking them to make sure they all have the right polarity. Because I didn't do it. I don't know who did do it, and I certainly don't know that they are correct. Yes, they all appear to be fine, or at least the right way round. Now I've marked 5 volts on here because we're going to need to know that. That pin next to it, which is A20, has got a lot of scratches on it. as if that's been prodded a lot. So I just did some research on the HALT line, and that is controlled basically by the CPU and also by the Gary chip. Now we put in a new Gary chip which came out of the Denise. We know that that's fine, and there's a pull-up between HALT and 5 volts, which is a 4K7. It's one of these resistor packs. I'm not sure which one it is. I'll just check the schematic. RP14. Okay, it's this one here. For what that is worth, it's 4K7. So we should see 4K7 between there and earth. I'll put that there. Right, so we need to go between HALT, which is this one, and 5 volts, and we should be looking for 4K7. If we don't get 4K7, there may be a short on the board. That's as close to 4K7 as makes no odds. 4688. Okay, so there isn't a short, and there isn't very much in that particular circuit. It just goes between Gary and the CPU and, well, the Zorro slots, I guess. We don't have any Zorro slots. We've got this expansion thing, but there's nothing connected to it. So have we got a suspect CPU? It's easy enough to change that. We've got a spare one because we can pull it out of the Denise, which is currently not using it because it has that 68030 in it. So let's get the 68000 from the Denise board. So let's do the strappy. I'll unplug that so that it's definitely not on. Going by the creaks, it hasn't been removed before. And this is the CPU out of our Denise. There we go. Now let us plug it back in and see if it goes. Right, we still have the blue screen. 17. That is still low. We've got no bus activity. So that's exactly the same. I've been enjoying the special discounted price purple PCBs from our sponsor PCBWay. I hope you have. More about this particular PCB in an upcoming video. If you want to make your own PCBs, then all you have to do is get the design files from the web or from your PCB design program and upload them to PCBWay. You can even use a shared project from PCBWay's own website and select a few parameters such as the quantity that you want, the color and so on, and then off you go. Starting from $5 for 5 boards, and in about a week then you will get your boards back. There's a new special offer for the holiday period. You can get matte black and pink PCBs for the same low price, $5. Don't forget the other services, 3D printing, CNC machining, sheet metal fabrication and so on, and check them out, www.pcbway.com. Okay, so what I've done is I've pulled the HALT pin out so that it is isolated. That way we'll see whether the CPU is pulling that pin down or whether the Gary is pulling that pin down. And that will tell us something, hopefully. Look. Right, power is on. Let's have a look. What do you reckon? It is low. Reset is high. That is most definitely low. Okay, so we may well have some sort of bus conflict. Possibly something is being enabled that shouldn't be enabled. So we're going to have to start looking at other chips. So this is my Denise board, and what I'm going to do is transplant the major chips out of the CDTV, which I've already got here. So we've got two CIAs, we've got the CPU, we've got Gary, and we've got Denise, and I'm going to put them into my Denise board and check that they are in fact okay. So let's start with the CPU. Got my strappy on. That's the CPU from the CDTV. Plug it in, and let's just check that it works. And we get the workbench screen. It's going to be red because there's no floppy drive plugged in, but that is fine. So let's go on and check the other chips. Yep. So all those chips are working fine in another machine. We have confirmed that. So I've put the chips back. I've put a check mark on each of them so that we know that they've worked. I also sprayed the contacts and the sockets with some contact cleaner. So let us try the machine again and see if we are still where we were. Okay, so power is on. Let's plug it in. I'll put that up there. We'll expect to see no change. Oh, we've got a black screen. That's an improvement. Doesn't appear to be booting though. Let's change this jumper and see whether it boots into pure Amiga mode. So turn it off, power it off, take the jumper out, power it on, turn it on. No, it doesn't. So let's look at the CPU again. So that's read write, doing nothing again. That's our clock. That's going to be ground. A bit noisy. This is going to be our halt signal. Still low. That's our reset, still high. That's VMA, whatever that is. And that's our E signal. Okay, so objectively we're not any better than we were, but we do have a video signal even though it's doing nothing. So that's probably because we took that out and cleaned the socket. I can clean the socket of these other three chips and see if that does anything as well. I'll come back in a moment. Right, this is just contact cleaner ordinaire. I don't have Deoxit or any of the fancy ones. So dry off the excess. So the area of most concern from a reported number of failures perspective are these two static RAM chips here. These are 6116s in the narrow package, and these buffers over here. These are 244s and 373s, so buffers, latches. And we're just going to have a look at the chip select lines. So I'll power the unit. I've marked with a pencil which are the chip select lines and output enable lines on these. So let's just have a look. That's output enable. That's chip select. Chip select is active low, so that seems to be okay. Again, that's output enable, which I think is always on. And that is chip select, which is high, so that's okay. Let's have a look at these chips. Now it's pins 1 and 19, so it's at that end of the chips. So pin 1, what have we gone? 1 volt, so that's about 1.4 volts. Seems rather suspect. Just get an accurate reading. So about 1.5 volts, okay. And pin 19, which is about the same. Let's go to this one. I think they may be common, but not 100%. 1.2 volts. Yeah. And for these 373s, 1.6. That really does not seem right. These are driven directly from Gary, and there's nothing in between them, so I suspect either there is a fault in these chips, or there's a short or something, a solder bridge between. Now these caps were put on by somebody else. We need to check the soldering underneath the board and have a look. So let's do that. Okay, I'm going to start by reflowing the Agnus and then cleaning that, and then I shall go through the other capacitor connections and reflow those and clean those, particularly these ones here, because I think that is where the most likely bridge is going to be. So I'm just going to reflow these. Let's put some flux on. I'm going to use liquid flux because I want to use it up, basically. Okay. No guarantee that's going to work, but I've cleaned it up and reflowed it as best I can. So I did also replace this capacitor because it was kind of flopping about, and the only way I could clean it was actually to pull the pins out rather than just heating it. So I put a new one in there. That is why it is no longer red on the top. Probably a different brand as well, but never mind. Right, so we'll plug this in and try it and see if we're in the same state. If these are still indeterminate, sorry, these ones, if these are still indeterminate, then we'll take them out and socket it and see what happens. Okay, here we go. We still have a blue screen. It's weird, sometimes it's blue, sometimes it does go black. Let us just check these. So, pin 1. still 1 and a bit. Pin 1, still 1 and a bit. 19. 19. Now I do have replacements for those, so we can put new ones in. But I think at the very least we're going to take those out and socket them and see what pins 1 and 19 do without the chips in. So here we are again. I've got the 244s and 373s removed and sockets put in, so we can measure what pin 1 and pin 19 are with those chips out of circuit, and that should just be connected to the Gary. Now we do know that the Gary works, so I'm expecting that we should see correct signals on there. If not, then we know we've kind of got some sort of short and we can measure that. Right, there we go. So on the 244s, pin 1. Pin 1. Pin 19. Pin 19. Pin 1. Pin 1. Okay, so I am a complete twat. The Gary that I put in here was in fact a Denise 8373R4. What it should be is a 5719. So I put completely the wrong chip in there and then wondered why it didn't work. So okay, I have now got the correct chip in here. So let's see what happens on our pin 1 and pin 19 on these empty sockets. Right, the fan comes up. This is pin 1 on the 244. That is high. Pin 19, that is high. On the 373, that is high. That is high. That is much better. That is much, much better. So I'm going to put the chips back in and see what we get. We still get nothing. Now on the latch signal we are definitely getting a signal. Pin 1 we're getting high. So let's have a look and see what our halt signal is doing in our bus and so on. That's our clock. Well, that's high now. I've forgotten which way around they are, but they're both high. And I'm getting stuff on the data bus. We get so that's a yay. But if I look on the address bus, oh no, I'm getting stuff on the address bus too, so that's a yay. Or at least I was. I appear to have crashed it. That might have been me accidentally shorting two pins together. Let's hit reset. There we go, yeah. That's probably just me crashing it. So we've definitely got bus signals now. Okay, I've got terminal set up, plugged in at the back. I've got the diagram in. The jumper is set to be Amiga only. Camera's running. Right, power it on. And we've got a string of zeros. You're probably wondering why I've got the board off again. I was watching a recent video by CRG where Glenn took an Amiga 500 Rev 6 and converted it to be an A500 Plus, and he used this exact same adapter board on that. And while he was doing that, he mentioned something that I thought, aha, there are two things that I didn't know about this adapter. Okay, first one is there is a pad here that you put a 100 nanofarad capacitor on if this Agnus is a VBB type Agnus, and if it was, it would have the letters VBB written in that area there. So that's fine, it's not. But the second thing, and you might notice down here, it says A20. There is obviously a broken solder connection there, and I have wondered about on this CPU, there was this evidence of something having been soldered to this pin, and I had wondered about that. And the fact is that is A20. A20 also comes out on the Gary at pin 36, and I've marked that there on this one. So we need to have a wire that goes from this pin to this pad here, and there isn't one. The A500 has online descriptions of the PCB where you can trace it all through and you can follow every line and so on. I've followed the A20 line on this board. As far as I can see, it basically goes from here to here, and there is a via somewhere on this board that takes it somewhere else, but I couldn't follow where it went. But basically, unlike the A500 where there are some convenient pads that you can take it from, we've basically got to take it from here as being the nearest point. Now I'm not going to attempt to solder to the pins of the actual chip. I'm going to go from underneath, and I've already marked with Sharpie where it is on the underneath. I've also marked where it is on the Gary, just in case we want that. But I think what I'm going to do is take it from here, solder it on the bottom, route it through this hole, which is not actually a screw hole. The screw hole is this one, up through here, and then bring it out down to the little adapter board. And maybe that will fix the problem. Actually, it won't, because let's have a look at this adapter board. Okay, and I've beeped this out with the multimeter. That end pin is not soldered to the PCB, and similarly on the opposite corner, that end pin is not soldered to the PCB. And then don't know if we can see it on here. That corner pin and that corner pin need to be soldered. There are no shorts. I beeped it out and checked, but those corner pins are not soldered. And if you look at it from the side, you can actually see that the you may be able to see. So we need to fix that. I'm going to desolder that and plug a little DuPont connector into there, one of these angled things, and so that will have a connection that we can plug that into, and that will mean we can take it off the board if we want. Another thing that we can do is we can put an 84 pin PLC socket into here, just like one of these, and we can plug in an ordinary Agnus chip into that straight as it was, and have a regular 1 meg Amiga as it was originally intended. Another thing that Glenn highlighted is that these PLCC sockets that are quite thin do have a tendency to bow out, and that can cause them not to make good contact. Don't worry. Right, I'm going to start off by doing this. I'm using the thin solder, and we'll put some flux on. Chunky tip, but it's got a wedge connection, so hopefully that will slide in. Yep, that's done. And let's do the opposite corner. Same thing, nice blob of flux. Right, bit of solder on the iron. Right, just clean that up, and then we can go onto the main board. We just need to clean this A20 hole out and fit the new connector. There we go, a bit of wire that was stuck in there. Okay, I've got a wire with a DuPont connector on the end, and I've pulled some of the edge off it. Then I'm going to feed it through there and turn the board over, and we need to solder it to this pin here. So I'm going to route it just so that it doesn't go over any other pins. There's plenty of cable there, and I'm just going to use some Kapton tape to hold it down. And we'll do the same on the other side. We'll route it nicely. Then we put this back in. There you go, that's on. So we could give that a try. Here goes nothing. I'm going to have to reach across the camera. That's the mains on. We've got the front panel light. Okay, here goes the power. And nothing. We do have that light on. It did flicker, but we've got nothing on the screen. I've now got some of these sockets, so I can take my regular Agnus, which has come from my A500 8372A, and we can use this socket, replace that with the original Agnus, and see whether it actually still works. Or rather, we can see whether it actually does work. So we can then eliminate or otherwise this entire assembly from the problem. So I've got my strappy strap on. Let's take this board out. It's a little bit tricky when this is not screwed down. Now pin 1 is facing that way, so we can just plug this into the socket. Hopefully. I'm not 100% convinced that that's a good fit, but there we go. So the Agnus is in. That's the original Agnus. I'm going to put something underneath that because I don't want to take it off because A20 is still attached to it. That's a cardboard box with something in it, but it's a cardboard box. So that will do. We'll look at the terminal output this time and see what we're getting. Okay, I'm not recording it, but we can have a look. The terminal window is open and we'll go up and have a look at our classic blue screen and see if it's still doing the same thing. Right, okay. Power to the unit. Let's switch it on. Does nothing. That may be because this is not a very good connection, but we shall just poke some signals and see what we're getting. Let's just, so data lines, address lines, okay, we're not getting a clock, so that suggests that, and I think the clock comes from Agnus, so that suggests that this connection really isn't actually working that well. That's a shame. I was hoping it would show us something. Oh well, it was worth a try, but that is very loose in there, so, or it feels kind of loose in there, so I'm fairly sure that that's not making a very good contact. Yeah, just, which is a shame because these are quite thin pins as opposed to these chunky thick things. So let's plug this guy back in. We are switched off, and we're switched off at the mains. And this is in Amiga only mode. Interestingly, we're still getting nothing coming out of the serial port. But we've got data and we have got addresses, some of them. At this stage I don't quite know where to go next. I feel like we've got an issue with chip RAM because we had that problem there. Somehow we've lost the output to the serial port, so I'm not quite sure what's going on there. It may just be that socket. We've replaced these, so I'm fairly confident in those. This static RAM does seem to be okay, and the CS lines were okay. Could be these other 244s. Let's have another look at Denise. So of course we're getting nothing coming out of the colour pins. But we are getting pulses coming out. Or at least some pulses coming out. Or possibly going in. That's our dot clock coming in. So we're getting our clocks. What we're not getting is any data. There's a whole bunch of buffers. I think this video's gone on for quite a long time and we're not really getting anywhere, so I'm kind of out of ideas at the moment. I think there's something going on possibly between the CPU and the bus and stuff out there, so it may well be one of the interface chips is dodgy. I don't know, there's quite a lot of them. I think we'll come back to this and have another go next time and see if we can get any further. If you've enjoyed what you've seen, please give this video a like. Check out my Patreon for some exclusive videos, and that is a great way to help out the channel. Subscribe and do all that other good stuff. It doesn't cost you anything. Some of the videos on Patreon are even in the free tier. So I'll see you next time. See ya. Bye.